Is this working? Okay. Good day, folks. A lot of people have been asking about the power cells and how to build them, and I want to keep everything as open source as I can, no secrets. I've explained in some previous videos how I was making them, and the original concept still stands pretty good. But I've come up with better ways, and I want to show you this because a lot of people, I guess, they haven't seen the earlier videos, and I'm going to try this live just to show you exactly without any editing here to so people can better understand the whole process from scratch to finish if this is any help. So basically I'm getting ready here for a 3-cell stack. Okay, so some materials is the hot glue, the glue sticks, and like a syringe, which is going to be very helpful without the needle obviously. But this is for the PEG electrolyte. It's a lot easier to manipulate with one of these. And I've got these felts here that I just cut to my template here. This is going to act as the insulator layer in between our cell stack. Here we want to keep the cell stack as thin as possible. And basically, I'm going to show you how I mix it, and what you're going to want to have. The PEG I keep talking about is this, in case you don't know what it is, and it's sold in Canada as Relax, and it's does it say here? Yeah, polyethylene glycol 3350. So that's the stuff here, and it comes as a white powder form. And by the way, because it's a laxative, it's essentially non-toxic, so it's good to work with, easy to get if you're in Canada. So that's the main active ingredient. And when I started making the cells with this, I just made a little bit of water, enough for it to become a paste, and just put my electrodes in this and let it settle within a couple days. I found out a process that makes it better and easier to work with. And I'm going to show you how I mix it. And something else here, this is the copper oxide powder, which is, I like to keep like one part of this out of 4 with the PEG, and I'll explain that. As you've observed in my previous videos and others that have been replicating these quantum cells, because what happens is we are using a solid state electrolyte. So the ions can't freely move through as it would be a perfect conductor like salt water and acidic base, whatever. So your ionic flow, as I've explained in previous videos, is more like a hopping mechanism. It hops from one point to the other from the lattice. And obviously that creates little bursts of current and AC. So the AC transients we've been observing, that's part of the mechanism. Now, of course, when you first build the cell, there will be a certain amount of condensation in there. So you're going to have a little bit of electrical chemical, which we don't want to have, you see. But at first, the cells will give you like that 1 volt or so. And as they dry out, they may go down to 0.6, 0.7, unless you condition them. You see, what's going to happen is there's a conditioning process as well, because what we want to do is when the cell completely dries out and it acts exactly like a solid state electrolyte like we wanted, because we don't want any corrosion or any of that funky stuff going on. That's what our goals are. So what happens is, because the ion hops instead of natural flow, it's a little less efficient. So you don't get as much current output out of it. So that's why it sort of drops in voltage a little bit. So to compensate for that, we can use the electret-like properties of the PEG. So we have to condition it to align the molecular dipoles. So once you do that, you permanently create the electret effect, which gives it a magnetic field. In other words, the AC, you amplify the AC transients of the cell. So that makes up for the drop of voltage you get as the PEG dries up, and it brings it back up to close to the potential you were getting originally. Now, what happens with this is to be able to efficiently, because it's really flunky, the copper oxide is where it comes in, because the copper oxide has diode-like properties due to um, the P properties as a semiconductor. So this powder here mixed with the PEG allows us for a sort of very crude but a form of self-rectification. So the AC pulses self-regauge the cell, giving us what appears to be, that consistent 1 volt AC or so once the conditioning process has been done. Now, I also have this foil tape, which I've used for my cells. You see, as I've explained before, if you're going to build cell stacks, they need to be all in perfect symmetry because of DC systems, right? Because they get all flunky. So it's best to have templates and to cut everything the same size, or else you're not going to get the behaviors you want with these cells. So I've predetermined, this is going to be my first plate, and I've got a little contact sticking out here. And this is going to be my last plate. So I use magnesium, which is the best I found so far, along with conductive carbon I found on the internet just for searching conductive carbon for fuel cells. So basically, the carbon doesn't corrode, and the magnesium so far with the other cells, I've cracked one open by mistake when it dropped after almost a month, and there was no signs of corrosion. So that's a very good sign there. That's what we want in the dry cell action here. So essentially, I pre-made my plates here. So I've got one carbon side here, which is going to hit on the peg, and then here, which is the bridge here for the cell, and then the insulator underneath here. And then I did the same thing for this one here. So I've essentially got all my plates ready here. So I've also got the oven running because this is part of the conditioning process. So I guess we're going to mix the solid state electrolyte first in a liquid like paste. And I'm just going to move over to the computer to see if anyone's logged in, they have questions or anything for a moment here. Countertops, yeah. All right, good, good. Um, so now I got this bucket jar here. So I'm going to start with 4 parts. I don't think it's going to be enough here. So we're going to go 8. So this is the scoop that comes with it. So I'm going to count 8. 1, 2, 3, 4. Actually, maybe 4 is going to be, no, 4, 5, 6. Maybe 6 is going to be enough because I only have 3 cells. But that's got it. 6. I was pretty well close. 6, 7. Remember, I'm live, so 8 scoops, which took about a quarter of this stuff, $30 down the drain. But anyways, for the sake of experimentation, so what you're going to want to do here is add the copper oxide to the mix to help with the rectification effect. So I'm just going to add a couple of spoons here. And this is the black copper oxide, by the way. And that's all you need. And then you gotta, I use a coffee stick, bamboo stick here. And we carefully mix this here until we get like a grayness to it. And then it's all evenly mixed. And again, this is to help with the rectification of those AC transients, especially once we've done aligning those molecular dipoles with a permanent. So now you see there's still some strings of white. It's not properly mixed. You want to ensure that the mix is as even and symmetrical as we can have it. So, take your time But try not to breathe the copper oxide because that part of it might not be so good for you. But it's getting there. It's getting that grayish. You don't want to go too much on the copper oxide either because you want your peg to be the primary. So that seems like nice now. So what you got to do next is I found out it works a lot better if you have hot water. So let the water run for a few minutes at hot. And that, because it's heat sensitive, the peg melts. So we only used a little bit of water to make it into like a thick paste. And then we put it in the oven in this, because the plastic could withstand the low heat, for about 15 to 20 minutes. Then it will become like a very translucent fluid. And then we can actually siphon it up with this here and spread it where we want. But once we get to that part, I'm going to use the hot glue here and make a little mold all around it, like a spacing, so that the mold, once it settles, creates a little bump here so that we can fill that out with the peg and then slowly put this plate here on there, and then we do the same thing on here, all around a square inside with the hot glue. Let it settle for a few moments to have that lump, and then fill this in, and then keep the cell stack going. You got to be careful here because I need this to be connected. Just by showing you folks, I partially disconnected it. So, blooper number one, I'm going to make a new contact here. So very sensitive. Don't want to move this around too much. Actually, I think I got it again there. There we go. So I use this here to make the contact, and this is the insulator for the cell stack. And the whole idea is we're going to keep going up like this. And then once our stack is done, what we're going to do is we're going to condition for about half an hour with a Bedini motor the output. So what that's going to do is going to line up the molecular dipoles with a permanent field as it cools down and hardens. That's the solid state electrolyte here. Now, the reason I'm using a Bedini is because, as some noted in previous conditioning attempts, when the peg is wet at first or moist, it's almost a dead short, but dissipates as it dries out. So most power supplies obviously don't like dead shorts, right? So that's been an issue for some people. But when you're using the back EMF pulse of a Bedini, shorts doesn't matter. So the Bedini keeps running. It gives a nice high voltage, and I found it does excellent. So we may as well use things that work and are efficient. So just trying to explain my logic as I'm moving along here. Just gonna go here. So let's start with mixing the electrolyte. So I'm just gonna start with a tiny bit of water in here. See, I just put like a few drops, and then I'm mixing that. It's nice and warm, so this turns into like a gel. It looks like I, haven't had it enough. So we put another little bit of hot water in here. Keep mixing this into like a mud. That's what we want, is this mud. We need a little bit more water in there. You just need a little bit at a time, because if you put too much, then you're screwed, So there we go. The consistency is getting pretty good there. You see, it's still grainy. We don't want that grain, so the peg needs to completely melt, but the consistency is perfect. So to facilitate the melting, I'm going to put that in the oven for a few moments. Just make sure I've got it nice and mixed here. So for those who are just coming on, this is the solid state peg. This stuff here, the Relaxa glycol, the polyethylene glycol 3350, with a couple of spoons of copper oxide powder. That's to help with the rectification of the cell to make up for when it solidifies. So instead of getting half a volt, you'll be able to recover most of your 1 volt or whatever the potential of the cell is. And that's determined by the anode plate, which is your metal plate, and the surface area and whatnot. So now that I've got this mixed, I'm going to throw that in the oven. I'd like to give that maybe another dab of water. That's it. Just to give it more. Okay. This gets very messy, by the way, so I can just use one of these spare. So I'm going to put this in the oven now at very low heat. I've got to keep warm setting. So unfortunately, folks, this is going to be about 10-15 minutes. So we're going to stand by here and see who's on the chat. So what's the amperage? Well, the amperage varies depending on how you do it. The amperage can be anywhere from a couple milliamps to maybe 25 or so. If you stack them up, you get a higher potential. So once you get to, let's say, as crazy as John Hutchison did with 100 volts or so, that becomes a few watts, you know. So nothing major to begin with, but we have tricks to... They respond to piezoelectric vibrations, frequency. They're self-regaging. They respond to a negative pulse. They give you back a stronger kickback, kind of like inductive. So once you start putting all those mechanisms together, you can potentially set something up where the cell's output can be recycled into like a resonant Tesla coil reactive stage and then sent back to the input as a pulse. And it will feed back like that. So what's different about this is it self-regages and keeps amplifying from the pulse because it's able to make up every pulse the milliamps from the loss through the loop, right? So you could probably triple the efficiency by just doing that. But one thing at a time. Right now I'm just experimenting with different geometries of the cell and the solid state electrolytes instead of non-solid state. There's crystal methods. It's a bit of a hit and miss. Every batch is different. I'm not too fond of that. Bedini played with that a lot. Then there's the more exotic stuff like the barium crystals and the barium ferrites and all that, but very difficult to get your hands on. So not everyone can. And I found out through experimentation, this stuff here does much of all those exotic materials that you can work around with the kitchen that's non-toxic. So with that said, here's another one I have, which has been running for a few days now. I like this because it's portable. I can show it off. See? And there's the LED there. That's solely running, and that's all it is. No tricks. Solid state, dry, and it's been running like that now for a while. So I just like keeping it around as a little, memory, as a little novelty item to say, hey, see, there is sources of energy out there. Joe Thief, yeah, I did that with the other cells. No secret there. I like not doing that because it's cool to see that it can run it without. But on these smaller cells, if you look in my old videos, I have all that. I took a few of these old cells here, which was some of my first cells. A couple of these ran a Joule teeth no problem in bigger, brighter LEDs. But um, I haven't been able to run it really, really bright up until now without any kind of tricks, as one people would say. So I like this one a lot because there's no oscillator, there's nothing like that. Though I can, of course. Would be practical for cap dumps, right? If you want to charge like a motorcycle battery or something with it, why not? But I like this for simplicity, right? Because I can show it off. People, when they start seeing circuitry and everything, they know what's the trick. There's a trick. But this is very, very analog in simple terms. So it's easy to show, and see and visualize this way without any complex systems. So I think this one here is going to be my showcase one. So I'm still heating up. I'm heating up the solid state electrolyte, which is not so solid at the moment, but that's just because we're preparing it. It hardens up and dries out, but much easier to work with. So I may as well set up the plate for my first right here. So I've got the glue gun here. I'm going to carefully set up like my little mold. I got some more glue here because I'm going to run out. We may as well build a little. So there's going to be that one, and then this one here, and then. So these three here are going to have. I'm going to start with this one. This is going to take more glue than I thought, but that's okay. I've got a lot. It's dollar store stuff, so. And this is a cheap gun, so I can only do like one side at a time because the heat stops. So just give it a break. But yeah, this creates a little lump so that the solid state peg can settle on there. Just a really thin layer. And then the carbon felt, which would be this one here, would rest on there and mold into place. And then we do the same thing. So my oven went off here. So this is the wonders of live. I can't fast forward the heating up because I want to make sure that the this stuff here is well disintegrated, less granule residue here. And what I notice is it solidifies more into a crystal-like lattice. It's as you've seen it here with these cells. You know, it's not so much of the paste; it dries into very almost see-through, shiny, crystal-like. This is what we want to achieve. So, just testing out what we're at here. We give this a bit of a mix. It's going, I can see it. So now, maybe the rest of my glue, I can continue where I left because the gun gets too cold and won't melt the glue. And that's okay, we have enough time here. All right, here. I know I could have done a better way, like some spacers or something, but I don't have that here, so I figured I'll just use what I got. And this is what I got. This is what I'm going to use. Takes a little more time, but as long as we can create that little barrier, that's all that really matters. It's almost like icing on a cake. There we go. One of them's done. I'm going to give the glue gun some time to heat up. So yeah, the whole idea is we're going to put a thin layer of peg in here, then put the first plate, and they're already connected. And hopefully something's going to happen. No guarantee this is even going to work. I'm live here, so I might get a short or something. And whoops, back to the drawing board. It's not always perfect the first time, folks. Actually, hardly ever is. I'm actually taking a chance here by doing this live and risking making a fool if nothing works, and I don't know why. But at least I got the other one there. I'll just go, look, everyone. I'm not full of BS. It works. It's just I'm not there yet, but at least I have this one to show for. The cell for the piezo plate. Okay, where is that? Right here. It's very difficult because of the, but you got the magnesium plate on the top, and raid laying is one side. In the middle there, it's a round. That's the piezo plate. It's the same thickness. And on the bottom here, I cut the same round. The carbon felt sits in there. And the thickness you see of the peg is the thickness of the piezo capacitor. So each side of the piezo, one side touches here, the other side touches the carbon felt. So it's connected in parallel, you can say, with the electrodes. And this is just here for contact because it digs into the carbon felt in the bottom here. So you can see a bit down here of the piezo that's right on top. I mean, in the bottom, that's sandwiched between the electrodes. Sorry about the hands. I don't see the view unless I come over here. So now I'll be able to do another plate. This one right here. This one's doing well. My glue's starting to give it another break. See how this stuff is doing. Let me give it a mix. You can see it's starting to get more like a paint instead of a grainy. See? It becomes more like black paint. Keep it going. It's almost there. At some point, you'll be able to siphon it up with this here and just spread it in there. Hopefully, I made enough. This stuff is a little expensive, but give her another 10 minutes maybe. And while we're waiting, I may as well keep showing this one here because I'm really proud of it. No jewel thief. Just basic analog, pure potential difference. So it's pretty, it's really noticeable. I mean, it flashes the camera and distorts it. Before I trip on the cable of the camera here. So yeah, that's what's going on with the power cells. Just trying something here. Hopefully it's gonna work somewhat. That one did good. This one up there. It's a wonder of glue, right? You've got all these stringy things after. So move that out of there. Go. Now to do the last plate. Gonna wait a few more minutes for my hot glue. I use it too quickly and it can't keep up. No, it's magnesium. It's always magnesium that unless I specify, it's magnesium. It's what I found that works the most. I've tried a whole bunch. I've tried zinc, I've tried tin, I've tried copper, um, all varying readings, but this is the one that seems to work the most with the carbon felt, anyways. So we stick with that since it works. So let's see. If I can do it here now. This is just to kind of like add a little barrier so the solid state electrolyte as a liquid could settle in there without over splattering on the sides and shorting out the cell as it hardens. Of course, I could have used something better, spacing or whatever, but this is all I had, so this is what I ended up using. So now that's done. Let's connect that and let that dry. I would say it's the electrolyte because if you do research into the specifically this electrolyte here, it's got dielectric properties. It's got electret properties, very unusual electret properties, like at room temperature electret properties. So even without conditioning them, they will somewhat condition on their own from the additional as it's wet, as it dries out for a few hours, you got minimal, but there is some electrochemical, typical galvanic like reaction. And during this time is enough for it to condition. So by the time it ends up being completely dry, you're feeding mostly off the electret effect and a little bit of hopping in the ionic flow. So to be able to enhance that, this is why or lining up the molecular dipoles as soon as the peg is put in here and is still in very non-solid form. As it solidifies and cools down, we're conditioning it. So this way here, once the cell dries up and there's very minimal ionic flow, the electrode properties kick in, as I've explained previously, and compensate for it. So you end up having about the same voltage as if it were a wet cell without it being wet, no corrosion and that sort of things, and all the benefits that come with it. So I would say initially it's galvanic, but then dries out and becomes more magnetic, electric, piezoelectric. It's very responsive and reactive to external fields and vibrations, even temperature. You can pulse it in reverse and it'll send you. I've done that in a video demonstrating that. A short pulse gives you a stronger pulse on the output. So all kinds of unusual, interesting, and partially documented, mostly done in lab right now, but it is being explored. But nobody like this is doing it to our scale, and trying every possible combination and being public with it, anyways, like I'm trying to. So, but that's the thing, right? So, conditioning it is completely optional. But as I've said, within a few days, as the solid state it dries out and becomes a dry cell, it really lingers the ion flow, and then you're dependent on a different system. And at the quantum scale, it's ion hopping. So you also notice these fluctuations of AC and random current bursts. That in one case, I almost blew out one of my LEDs. So actually, conditioning it helps with that because it kind of like programs the cell so it knows how to behave. And a little bit of copper oxide is also part of the magic, as I think, because it gives you the rectification properties of those AC transients that allow you to charge the self-capacitive properties of the cell, so you end up with your solid 1 volt or so per cell once they're dried out even. So yeah, there's several things going on here. I think that's pretty well nice, and oh yeah, it's all fluidic now. So I'm gonna give that a mix. Oh yeah, see, look at that. Perfect. Now I can easily manipulate this stuff. It's like black paint. See, no more graininess in there. The peg's perfectly melted in there. So now before it gets too, because it solidifies real quick. So I'm going to try and do this without screwing up. Bear with me. This is our first plate here. Go like this for convenience here. Okay. Suck up a bunch of this stuff. Ooh. Carefully soak it up with the black. This is the peg stuff. Just adding a thin layer on there. And again, same thing. Make sure it's filled just enough to fill the surface of that little area we designated for it. We want to have enough that also okay. So now we're going to put the first one here on there, like that, on there. What's good too is to have a bit of a layer of that on this side here as well. Just a little layer. So to add a bond. Now hopefully go like this. Go like that. Just gently add pressure. Like that. Make sure my carbon is soaking it up. Yep. Okay. So now, should we have this one here? Same thing. It's already starting to harden. Gotta get quick. This stuff really hardens quick. I'm in a bit of a mess here. I'm trying to hurry up. I don't want to ruin it. Just kind of get a one-shot deal at this. Okay. So now this is this one here. Same thing. Add another, just as a bonding to this side here, just so we know it's going to touch. Thing is, the carbon absorbs part of it as well, which is actually a good thing. So now, see, there's a bit of a spillover. That's okay. Sort of expected that. It's okay. At least I can clean it up a bit. That's fine. It's fine there now. Okay. Makes a mess, but I'll clean that later. And then the final cell here will be this one here. Oh boy, I don't know if my stuff is still good enough. Yeah. Jeez, it's already, you can see a crust already wants to, you gotta be quick. Then a little squirt on here. Then we're gonna go like this, like that. Okay. So now to see if we have any kind of voltage here. I may have done this all wrong. Something tells me it probably won't work like this on the spot, unedited. Come on, just go in here. Okay. This one here and that one there. So I'm going to plug this one here, right there. Turn this on. Plug this one here. Ah, 6.6, folks. 6.6. 6.6. So now what we do is carefully make sure that the polarity is right. Yes, so plus is here and minus is the anode, which is the magnesium. So very carefully. Okay. Now we're going to condition with the Bedini. Here. Make sure I have the polarity right here. So I have this disconnect, and I'm pretty sure this is plus and this is minus on this meter. Plus is down here. This is plus and this is minus. Just gotta make sure I got the sometimes it's rare, but I had cases where it's not always like a plus and minus sometimes likes to play around. So the magnesium minus, yeah, okay. So we're right. So it's doing what it's been doing so far, where the anode is the magnesium and the cathode is the carbon. So anode is negative. So I'm going to go negative here. Negative. This is the output of the back here, the inductive kickback of the Bedini here. And I'm going to put the plus right here. And here's the power supply for the Bedini. I'm going to fire up the Bedini. Am I plugged in here? Around here. So now we're going to have to do this for about half an hour, because this will cool down and harden. And what we're doing now is we're conditioning it. So we're aligning the molecular dipoles with a permanent field. And that will give us our enhancement once the solid state peg is completely hardened. That will compensate for our slight drop in voltage because of the reduced ionic flow. So I'm probably gonna wrap it up because it's successful, it's working. We had our standing voltage. So this is not necessarily to boost the voltage. What this does is it helps the cell maintain that what we saw there, that 6 volts, once it gets hardened. So there's no drop or very minimal. So you don't need to do this, but if you don't do it, you'll notice a slight decrease in voltage as the solid state peg naturally solidifies and the moisture gets out of here. So just putting out all the information, and again, look how quick it's already forming a crust. So as soon as this stuff cools down, it wants to solidify into a crystal-like. So I'm just gonna, unfortunately, it's too bad I'm wasting all this. But what I could do, maybe I could like, I don't know if I can, I got an idea. Maybe I could recycle this and put a saran wrap over it and keep the air out and heat it up again, because it seems to be a good composition. You see how the voltage was nice there. I got a good mix here. It's not always straightforward mixing the peg, but this mix did very well. So I'm going to try and keep it. Because I know you just heat this up and it turns back into this paint like. And then once it gets cold again, it solidifies. So it's a good way to store it too. Okay. So now I'm going to put a saran wrap over that. I'm going to keep this mixture because it was very successful, as you saw. 6.6 volts. That's really good. It's half the voltage of the other one I showed you in the ice tray. Much smaller too. So see, just so I can keep this for later, all I have to do is warm it up and then siphon it with this for a future cell of others. So with that, folks, I wanted to be transparent about the current process and the conditioning and the ingredients and why the copper oxide does what it does and why it seems to enhance the effects of these cells. So I'm going to let you go now, folks, and this is going to be archived so anyone can watch this for future reference if they want to know how to build the quantum power cell. And I'm pretty proud here because we did it all, folks, on the fly with no major mistakes here, and it all worked out. I'm surprised myself, you know. I didn't want to do this live because I hate the potential bloopers, but I guess I'm starting to understand my stuff, huh? Just joking there. I don't want to make it sound like I'm being big ego here. Just happy it all works. I wanted to show everyone how they can do this. So just putting it out there and putting the information. And after half an hour, this will be ready. It'll do whatever I want to do with it. It'll be conditioned. It'll hover around 6 volts continuously. And it shouldn't need any reconditioning. So with that said, folks, have yourselves all a great day.